Today our discussion topic is graphs. So what is actually graphs? A graph G consists of a set of vertices and a set of pair of distinct vertices from V. These pairs of vertices are called edges. Okay. So if the pair of vertices are unordered, that time G is an undirected graph. But if the pair of vertices are ordered, that time the G is a directed graph or digraph. Here we see there are actually nodes 9 nodes there. But there is no direction actually. There is no order. That's why this is the undirected graph. And here we see that there is some direction from one node to or one vertex to another vertex. There is some direction. Since there is some direction, that's why this is known as directed graph. A tree can be also a graph. Here we see there 5 nodes. So each node is not connected with each one, but this is also can consider as a graph. Here, as a simple difference between a tree and graph, if we see that there is actually no cycle, there is no actually no closed path in a tree, but in case of graph, there are a lot of closed path. There are a lot of closed path. So that's why this is graph and this is tree, because there is no closed path. That's why this is tree. And since there are a lot of closed path uh, in this undirected graph and in this directed graph, that's why this is known as graph. So there are some terminology of undirected graph. So an undirected graph G, where a lot of vertices will be present, and there should be some edges also. So how we can write? We see that there are A, B, C, D, E, F, G, H, I. Those 9 vertices here. So we have listing vertices as V. So in the set of V, all of the nodes are including here. And in the edges of E, it represents how many connection of vertices present in the graph. Here we see that there is a connection between A and B. That's why we write here as a subset A comma B. A comma B in the second bracket, that means there is a connection between A and B. A comma C, it means there is a connection between A and C. B comma E, that means there is a connection between B and D. B comma H, it represents there is a connection between B and H. B comma I, that means there is a connection between B and I. Similarly, C comma D, that means there is a connection between C and D. There is a connection between C and E. There is a connection between E and F. And there is a connection between and G. And H comma I, at last it represents that there is a connection between H and I. Okay, so two vertices X and Y are adjacent if X comma Y is an edge in E. So C and D is adjacent here, and C is adjacent, F and E is adjacent. We can tell E and G is adjacent, E and B is adjacent, E and I is adjacent, E and H is adjacent, H and I is adjacent, as well as B and A is also adjacent. So what is a path? A path in G is a sequence of distinct vertices, each adjacent to the next. A path is simple if no vertex occur twice in the path. So we see that is there any path between A and G? Yes, there are actually two paths between A and G. So what are the path? The path, first path is A, B, E, G. Second path is A, C, E, and G. Those both paths are simple paths. But if we consider the path A, B, then H, I, then again B, E, and G. So there is also a path between A and G, which is not simple. Which one is this? A, B, H, I, E, E. Since B's presence twice in the path, that's why this path is not simple. So what is cycle? A cycle in G is a path in G containing at least three vertices such that last vertex in the sequence is adjacent to the first vertex in the sequence. So here we clearly see there is actually two cycle. First cycle is A, B, E, C, and A. That means A connected with B, B is adjacent with E, E is connected with C, and the last node C as well as connected with A. That's why this is a cycle. And here is another cycle. B is connected with I with connected with H with connected with B. So this is also a cycle. A graph G is connected if given any two vertices x and y in G, there is a path in G with first vertex x and last vertex y. And the graph G is not connected, uh, then we say that a maximal connected set of vertices is a component of G. So in the previous slide, we see that this is a connected graph. Okay, this is a connected graph because at least all nodes are connected via another node. Okay, here is a C and B connected with E. But if we cancel these two edges, that time it will not be a connected graph. Okay, there will be two graph actually. This is a graph and this is also another graph. But if we do not cancel those edges, that times this is called as connected graph as a whole. So the terminology for directed graph now is slightly different. Uh, we can say that there is a path between A to C. That means A comma C. If we write A comma C, that means there is a path from A to C. Then if we write C comma A, that means uh, there is a path between C to A. So is there any path from A to B? Yes, there is a path from A to B. So how we can write it? We can write it A comma B. But is there any age of B to any age from B to A? No, there is actually no age from B to A. So we do not write B comma A here. So the set of A's here, we see that A comma B, E comma H comma I, B comma I, H comma B, B comma E comma B, E comma A G, F comma E, C comma E, C comma D, A comma C, and C comma A. Those are the ages for this directed graph. And a directed path is a directed graph. G is a sequence of distinct vertices such that there is an edge from each vertex in the sequence to the next. So if I ask, is there any path from A to I? So we see that there is a path A to B and B to I. Yes, there is a path, but we have to go from A to B, then B to I. So we can go also A to B, B to E, E to B again, then B to I. Otherwise, we can go A to B, B to H, and H to I. So if we ask, is there any path from F to A? Is there any path from F to A? So the answer is yes. F to E, sorry, the answer is no, because there is no path from F to A. If we see F to E, then we can go to E to B, we can go to B to I, but this is the last destination. So there is actually no path from F to A. So in case of undirected graph, we see that there is always a path, but in case of directed graph, we see that there can be possibility that there is sometimes there is a path, a directed path, or sometimes there will not be a directed path. So a directed graph G is weakly connected when the undirected graph, if the undirected graph obtained by suppressing the direction on the edges of G is connected, and the directed graph G is strongly connected if given any two vertices X and Y in G, there is a directed path in G from X to Y. This is the case. So how we can represent a graph? We can represent a graph by adjacency matrix. So adjacency matrix, a graph may be represented by a two-dimensional adjacency matrix. If G has n vertices, let M be an n by n matrix whose entries are defined by. If there is an edge, just fill up by one. If there is there is not any edge, just fill up by 0. So here we see that there are nine nodes here from 0 to 9. So first one is represents 0. First column and first row represents for 0. Second column and second row is represents for 1. Similarly, the last column and the last row is representing the last value 8. So from here, we easily fill up the adjacency matrix, and how we can see right now. Is there any path from 0 to 0? No, there is no path from 0 to 0. That's why we put here 0. Is there any path from 0 to 1? Yes, there is a path from 0 to 1. Just put 1 here. Is there any path from 0 to 2? Yes, there is a path from 0 to 2. Yes, that's why we put 1 here. Is there any path from 0 to 3? No, there is no path from 0 to 3. Is there any path from 0? Sorry, is there any edge from 0 to 3? No, there is no path from 0 to 3. There is no age from 0 to 4. There is no age from 0 to 5, 0 to 6, 0 to 7, and 0 to 8. There is no direct ages. That's why we put 0 here. So in case of 1, we see that is there any path from 1 to 0? No, there is no age. There is no age from 1 to 0. That's why this is 0. Is there any directed age from 1 to 1? No. That's why this is 0 here. Is there any age from 1 to 2? We see that no direct ages. That's why 0 here. Is there any directed age from 1 to 3? No, that's why we put 0 here. Is there any age from 1 to 4? We see that there is an age from 1 to 4. That's why you put 1 here. So is there any age from 1 to 5 and 1 to 6? The answer is no. That's why we put 0 here. And is there any path from 1 to 7? Sorry, is there any age from 1 to 7 and 1 to 8? Yes, there is an age from 1 to 7 as well as there is an age from 1 to 8. That's why you put 1 here. So similarly, you can put 1 and 0 in this two-dimensional matrix, and you can find the adjacency matrix of this graph easily. So there is also another representation, adjacency table representation. You can represent it by two-dimensional array, or otherwise as you can represent it by a linked list. Okay. So there are actually nine digits. So there are actually nine nodes here: 0, 1, 2, 3, 4, 5, 6, 7, 8. So here 0 is connected with 1, and 1 is and 0 is connected with 2. So you just link 0 with 1, and then 1 link with 2. That means 0 is connected with 1 as well as it is connected with 2. So one has a age with 4, and one has age with 7, as well as one has age with 8. So just one is linked with 4, 4 is linked with 7, 7 is linked with 8. That means one has an age with 4 as well as has an age with 7 and 8. So here, in case of 2, 2 has an age with a 0, 2 has an age with 4, and 2 has an age with 3. That's why we write down here 2 is connected with 0, 3, and 4, and so on. So this is the case actually. So if you have any question, you can